In these notes, we're going to talk about vertical and horizontal stretching. So I've given us our functions for absolute, cubic, quadratic, and square roots up at the top just to remind us. And today we're going to be talking about a, which is the coefficient in front of our x that tells us whether things are stretching or shrinking. We have one example done here of an absolute value equation where our green function is the parent function, otherwise known as the original function, of y equals the absolute value of x. The taller function has been stretched by a value of 2, which is why it is y equals 2 absolute value of x. Whenever a is higher than 1, such as 2, 3, 4, 5, 6, 7, 8, it's going to make our function taller. Lastly, we have our third function, which is shorter than the parent function. And the reason for that is because our a, or our coefficient in this case, is smaller than 1. So it's between 0 and 1. 1/2 is between 0 and 1, therefore it's going to make our function shorter. So if we go down to these two examples, we're going to do an example of vertical stretching where things become taller and horizontal stretching where things become shorter. We already know that our absolute value equations are going to look like this, but now we're going to create a table to show us why. So first, we're going to plot f of x, and then we're going to do g of x. So f of x is our parent function. It hasn't been shifted left or right or stretched yet, and we're just going to choose -2, -1, 0, 1, and 2 to give us a sample on the left and right hand side of our graph. When I plug -2 into the absolute value sign, absolute values make things positive, therefore it would give us just 2. Plugging in -1, the absolute value of -1 is just 1. The absolute value of 0 is 0. The absolute value of 1 is 1, and 2 is 2. So if we go ahead and graph this, we have 0, 0, -1, 1, -2, 2, 1, 1, and 2, 2. So this is f of x, or our parent function. Now if we want to graph the same points for the x values, but plug it into g of x, we're going to get something different. So the absolute value of -2 is still positive 2, but now we're going to multiply it by our coefficient of 2, and that's going to give us 4. We're going to plug in -1 into the absolute value and get positive 1. 1 times 2 is 2. We plug in 0. 0 times 2 is 0. 0. We plug in 1. 1 times 2 is 2, and 2 times 2 is 4. We're now going to graph our x values and our new y values for our g of x function. So we're going to get -2, positive 4, -1, positive 2, 0 will stay at 0, 1, positive 2, and 2, positive 4. So just like we saw up above in our original example, when there's a coefficient of 2 or any number greater than 1, our new function is going to become taller than our original parent function. Now we're going to do an example where something or a function is going to get shorter. So this time we're looking at quadratics. We have x squared, that's a quadratic function. We're going to do the same thing that we did for our absolute value function and just pick 5 points and graph them both. So again, -2, -1, 0, 1, 2 are always the best points to pick. It gives us negative, positive, and 0 is always a good number to know. When we plug in -2 into x squared, -2 times -2 gives me positive 4. -1 times -1 gives me positive 1. 0 squared is 0, 1 squared is 1, and 2 squared is 4. If we go ahead and graph these, -2, 4, -1, 1, 0, and this will be our parent function, f of x. Now we're going to use the same x values that we used for our parent function, but we're going to plug them into our g of x equation this time. In this case, we have an a value that is between 0 and 1. 1/2 is halfway between 0 and 1. This means that our function should get shorter or come below our parent function. So when we plug in -2, we have 1/2 times -2 squared, which is 4. 4 times 1/2 is just 2. -1 squared is positive 1. 1 times 1/2 is 1. 0 squared is 0. 0 times 1/2 is 0. 1 squared is 1. 1 times 1/2 is 1/2. 2 squared is 4. 4 times 1/2 is 2. So we are going to graph our original x value points, and we're now going to graph our y value. So we have -2, positive 2, -1, positive 1, 0, 0, negative, oops, I definitely made a mistake. This should be 1/2. Both of these should be 1/2, sorry. So we have -1, 1/2, 0 is at 0, 1, 1/2, and then 2 is at 2. So you'll see that this function is going to be shorter or below our parent function because it has a coefficient or a value that is less than 1 but greater than 0.